episode of the Klingberg Wing Mark II development. I'm Rob Klingberg, your host. I'm going to take you today on a little journey as we experiment with making D-tube leading edges. And before we begin, let's talk a little bit about D-tubes and what they do and how they can be made. What you see here is the D-shaped section of the leading edge. It's the airfoil, the leading edge of the airfoil. It's attached to an I-beam spar. Between the I-beam spar and the D-tube, this structure has to carry all of the loads that the aircraft generates. The aft skins are strictly for aerodynamic fairing purposes. So this D-tube is probably the most critical component of the structure of the aircraft. It must be made accurately and must have a very high strength to weight ratio. What you see here on this sample is an early D-tube that I made experimenting with different construction processes. The outside is a 3-ounce E-glass woven in a 120 format. It gives a very smooth finish on the outer surface. The inside happens to be 5 or 6 ounce carbon fiber. In between the two layers is 1/8 inch thick Divinycell foam. It's 3 pounds per cubic foot for that foam. Here at the very leading edge, you see that the core material changes to a Nomex honeycomb core. This allows me to bend the materials around the mill mold that they're formed on. The Divinycell, if we tried to wrap it around that mold, it would crack. So the honeycomb allows me to bend it, and during the molding process, I fill it with microballoons and epoxy here at the very leading edge, and it all co-cures, and you get a nice solid, rock-solid leading edge that's not too terribly heavy. So this entire structure process is described in a little bit more detail in some of my other videos, but I developed this early on so as an experiment to eliminate the need for female molds. Female molds are generally very expensive and take a long time to make. It requires that you make a plug, and then you pull molds off the plug. You have to clean those up. It's a lot of work and very expensive. I've developed a process where we can make D-tube leading edges on a male mold that's very inexpensive. If you visit one of my other videos, the structural concepts, I believe, you will see how that mold is made. So before I mix up some epoxy, let me take a moment to talk about the materials that we're going to lay up today. Let me get this wing out of the way, and I'll be right back. So here I've stacked up all the materials that I'll need for the layup today. They're in reverse order. We have 10 mil Mylar. This is the outer surface. It forms the outer surface of the wing, and it creates a very smooth finish on that outer surface. The next layer is the 3-ounce E-glass woven in the 120 format. You'll see this is a very fine mesh. It gives a really smooth finish. That goes up against the Mylar. Next, we have a strip of unidirectional carbon fiber cloth. This is going to go right at the very leading edge. This is going to substitute for the microballoons inside of the honeycomb. This will reinforce the leading edge and give it the durability that it needs to withstand the normal ground handling. That'll go up against the E-glass. Now here's the core material. I'm doing several experiments here today, but this core material, even though it's the same color, is a different material. This is Airex foam. It is also PVC. Divinycell is a PVC. This is a PVC made in Europe. This particular material is 1.2 millimeters thick, about a 1/16 of an inch thick. And it has several advantages over Divinycell. It is more flexible without cracking. It has a finer cell structure in the foam so that when you wet out the cloth, you don't get as much resin transferring into the foam where it's not doing much good, just adding weight. And it is very durable. It's crack resistant, impact resistant. What I've done here is I've seamed 2 pieces together. I'm doing an experiment today to see if I can actually wrap this material around my male mold with this seam being right at the very leading edge, make sure it doesn't crack, and see if I can actually hide this seam, aerodynamically hide it, behind carbon fiber on both sides so that we get a smooth finish and nobody knows that there's a seam there. Also, on this side, I've attached a couple of rectangular shaped pull-truded carbon fiber rods. These are rods that I'm looking at to use as spar caps, and I thought it'd be interesting to see how it's going to come out if I just mold those spar cap rods right into the D-tubes layup. It just happens to be that they make these rods the same thickness as the foam. Comes in pretty handy, and I'm just going to make a little sample here. Now you'll notice that this piece is very narrow. We're just going to do the very leading edge portion of the D-tube. It is the difficult part to do, and this will suffice to prove out the method of forming. On the inside, be another layer of unidirectional carbon fiber cloth that goes over that seam, and then the inside surface is 2 ounce plus a little, about 2.2 ounce carbon fiber cloth. Very fine weave. You see here, this is made of toes that are 1,000 fiber toes or 1K toes. You'll see that there's some yellow lines on here. Those are Kevlar tracers. They come in handy when you need to orient the cloth in a particular way and make sure that it's nice and square. Finally, on the inside, it goes some 1.8 ounce Dacron fabric. This is a bleeder layer. It leaves a finish on the inside that is rough and accepts secondary bonding. Over the outside, we'll go standard vacuum bagging material. So now let me set these items aside, flip them back over, get ready to go here. So give me a moment to set up with some plastic here and get some epoxy mixed, and we'll get started. Okay, I have the epoxy mixed up, and now we have to work quickly. This is a very fast setting epoxy. It has about a 15-minute pot life, so we're going to move right along here. So we have our Mylar outer layer. I've prepped this material with a spray-on mold release, and it's not really needed. It's going to come right off this material anyway. It's very slippery, but just to be on the safe side, we got a little mold release on it. Now we lay on our cloth right onto the Mylar, and we can begin to wet that cloth out. The critical part about this process is to make sure that this cloth is thoroughly wetted and that it has all wrinkles and bumps removed from it. The vacuum bagging process will not significantly flatten this material. Should do a little stippling here to get this stuck down so it quits shifting on me. I've tried a variety of methods of laying this fabric onto the Mylar, some more successful than others. This is one of the better ways to do it. I've sprayed the Mylar with epoxy ahead of time, and then it gets difficult to roll the cloth out. But if you just lay the cloth in place, start sticking it down, as you saw, it can move on you, but once you get this fairly well stuck down in place, you can move right along. Take a little plastic squeegee and begin to push that epoxy around and get the cloth thoroughly wetted. This 120 cloth does provide wonderful mechanical properties, and it gives a superior surface finish, but it is a little bit harder to get the resin to work into it. Different temperatures, if I were working at a higher temperature during the summer, it would work into the cloth much easier. Likewise, if I were using an epoxy that was thinner, had a lower viscosity, it would also penetrate the cloth much easier. We want to make sure that this cloth is fairly wet. We don't want to squeegee it dry because we need a little bit of excess epoxy to bond the foam core in place. If there's not enough extra epoxy, you get a very poor bond to the core material, and that's a bad plan. Now, some ultralight aircraft are built such that the designer says, hey, you got to spread this epoxy resin with microballoons onto the foam to make sure that you have a secure bond. And for powered ultralight aircraft, that's probably true. I wouldn't doubt it. But in this particular case, if we were to wet out the foam entirely with epoxy resin, we could easily add 8, 9, 10 pounds to the aircraft weight. And when we're building a 100-pound aircraft, we cannot afford an additional 10 pounds or so. Now we have the carbon fiber. I'm going to lay that right in the middle here. and to tack that down. This is to reinforce the very leading edge and provide protection from ground handling damage and give some added strength to the D-tube. Just lay that right on the inside here. Work quickly with that resin. Now, initially, it doesn't look like this cloth has wetted out, but it is the nature of this unidirectional material that it takes a little while for the epoxy resin to work its way through the fabric. And we'll give it a few seconds here. I'm pushing fairly firmly on my squeegee to get that epoxy resin working. And it looks like we got her stuck down pretty good there. You can see some of the extra resin coming up. Now, because I'm doing a little experiment with the carbon fiber rods here, obviously not at the edge where they would actually be in the final version, but at an edge where I can at least see what it's like when it bonds to the cloth itself. I'm adding a little bit of extra resin to those rods to make sure that we have a firm attachment to the skins. Now I'm going to center the seam I'm experimenting with right over the carbon fiber, right in the middle there like that. And press down firmly like this, and now I'm going to work this Aerex foam, which is a PVC foam, into that first layer of fiberglass, which is the outer skin of the aircraft. Now, this Aerex foam is about 3 pounds per cubic foot. It's about the same as the Vindicel, but as I mentioned earlier, it has a very fine cell structure, so it's more resistant to picking up excess resin. Now, next layer of carbon fiber over that seam down the middle, and stick that guy on there. In fact, I think I'm going to do this a little different. I'm just going to lay in a little bit of resin here, right along that seam. This seam is already filled with CA glue to attach the foam together. That is another nice thing about working with these PVC foams, foam cores, is that they are resistant to standard sound and acrylate adhesives, so you need not worry about buying the more expensive foam safe CA. You can just use it directly right on. Regular CA, use it directly right on the foam. Everybody's happy with that. So we got the second carbon fiber strip on here, and we continue to work along briskly here. And you can see it's working its way into that carbon fiber slowly, working its way in there. Looks like I got a little dry spot there. You see little buckles like this come up, you'll probably got a dry spot. A little extra resin there. This experiment will tell me about what it's like to form this part. It will tell me about what it's like to have the carbon fiber leading edge instead of the filled honeycomb, and it'll tell me about that seam that's there. It'll tell me a variety of things, but what we're not going to get out of this is a weight. Because of how the sample is set up, the weight won't be inaccurate. We'll leave that for another experiment. Now I lay on the carbon fiber. Nominally, for D-tube, the carbon fiber would be laid up on the bias. That would help it take the torsional loads best. But for this little experiment, not critical, just simply not important, so we don't worry about it. Now you notice that it is kind of the reverse process here with the carbon fiber. We're adding the epoxy resin to the cloth after the foam core is already in place. And you're going to say, hey, Earl, isn't that going to put a lot of epoxy in the foam? Well, it certainly does get more epoxy into the foam. It weighs a little bit more, but this is the load-carrying portion of the D-tube, and it must be rigidly attached to that foam. No ifs, ands, or buts about it. It must be firmly adhered to the foam core. And to ensure we achieve that level of adhesion, I like to do it right on the foam. Now I see I'm a little bit out of alignment here, so I'm going to shift this cloth over a little. I went a little too far there. on the carbon fiber parts. There we go. Got that lined up better there. A little adjustment there, never hurt. Spread out the rest of this resin here. Now, the weight difference between Divinycell and the Arex foam relative to applying epoxy like this is significant over the entire aircraft. The difference of the amount of resin going into the foam will probably add up to somewhere on the order of 2 or 3 pounds, which is quite a bit of resin that's just sitting in the foam and not doing anything. So you might ask, gee, Raul, why would you use anything other than the Arex? Why would you use Divinycell anywhere? Well, cost. The Divinycell is probably half the cost of the Arex, at least in the suppliers that I've found. I have not been able to find it as a inexpensive product. I order my Arex directly out of Germany, and it has a price attending that type of acquisition. It is a little spendy, but we're trying to create a very high performance aircraft, extremely high strength to weight ratio. There are going to be times where we just have to succumb and use the more expensive product because it has superior mechanical properties. So there we are. We have our basic layup there. That is the D-tube, such as it is. Okay, so there we have the layers of the D-tube laid up. There's one more item to go on, and that is the peel-ply surface, or the bleeder layer. This provides a rough surface on a finished product, and it ensures that that surface is amenable to secondary bonding. When you come in with structural adhesives and want to put in nose ribs or attach the D-tube to the I-beam spar, you have to have the appropriate surface to do that on, and that's where this material comes in. Make sure that the surfacing agents that are in the epoxy come up through this cloth, and when this cloth is removed, it takes those surfacing agents with it and leaves exposed a textured surface that is appropriate for secondary bonds. So there we go. We have it all laid up and together, and it's time to put it on the mold. Let me get this stuff out of the way, and we're going to get the mold over here, and you're going to see how this, we're going to all find out together how this goes around the leading edge. So up we go. Okay, what you see here is the mold that I've been using to make the D-tube leading edges for my wing samples. You'll see that I've attached a layer of polyester plastic film here. This is 2 mils thick. I've just tacked it in place with some masking tape. This forms the mold release surface that we're going to put the D-tube layup on, and this prevents that layup from sticking to the mold itself. This is peeled out after the fact and thrown away. So let me grab the layup. Okay, so here we go. We have our complete layup here. That's the inside. That's the outside with the Mylar on it. I'm going to make one last check and make sure that I don't have any air pockets in that layup. It looks pretty good. I'm going to center that leading edge carbon fiber right over the leading edge of the D-tube. And I'm going to let this sit here for a second, if it will, if I'm lucky enough to get it to just stay there for a moment. And begin to bend it down and around. It's with the resin and so forth, the foam's quite flexible, and it's going around the leading edge nicely. I see a little air pocket forming here right at the very leading edge, and to ensure that those don't exist in the final layup, we're going to have to pull this Mylar quite tight. So I'm going to go with a little additional plan here. Let's let that set for a second. Stay. I'm going to take my gloves off, and okay, Okay, what you can see here is I've applied packing tape to the Mylar and then down onto the mold. Normally when I'm molding the full D-tube, the component actually runs down to about the red line here, and I use packing tape around the bottom and up onto the Mylar. I lay the Mylar sheet flat and then I roll the mold onto it and do the same thing on the other side. On the back side I have the same thing. I've attached I've attached packing tape to the Mylar and stretched it down tight, so we're pulling this whole unit down tight onto the mold. Also, I should note that when making the full part, this whole thing gets vacuumed down to the table, so it presses down on this Mylar and keeps it tight to the mold. Because we're only doing a partial of the D-tube, we won't actually be vacuum bagging down to the table, so there's the load is not as strong in this direction. We're just going to end up clamping it down onto the mold. So in that case, I've just applied some pressure to the layup by stretching packing tape down onto the mold. And as you can see, I've gone over the vacuum bag sealant that I have here, and I'll have to take care of that with a little bit of extra sealant. But I'm going to go ahead and set this up for vacuum bagging. Vacuum bag will go around here, we'll suck it down, and you'll all come back tomorrow with me and see how the part came out. We'll see what we got. But I think overall it has been successful because I have gotten the foam to go around the leading edge without cracking. The carbon fiber looks good. I don't see any seams or bumps showing through at this point. So this is a viable method. We'll be able to substitute the Aerox foam for the honeycomb core. There's no need to lay up the microballoons then. It makes the whole layup go a lot easier. Based on my experience from doing this prior. Some problems here with trying to do a partial piece instead of the whole D-tube. That would go away if we're forming the full piece. But you see the basic process. We have this molded on the outside of the male mold. Our finished surface is underneath this Mylar molding surface is essentially what it is. And we're going to vacuum bag it right on here. We'll come back and see what we have tomorrow. So hang in there. I'll be gone a day. You're going to be back in the blink of an eye.
Hello and welcome back. And here we are with the finished part. It's been several days here while I waited for some other items to come in that I could show to you. But I'm happy to say that my experiment of making the D-tube leading edge this particular way was very successful. I'm really happy with the results. The seam of the foam parts, the two foam sheets that I had right down the center, is completely invisible. The finish on this part is extremely smooth, as good as any I've ever seen on a composite aircraft. Very, very smooth. No bumps, no runs, no drips, no errors, as they say. Really a superior part. There are no visible or detectable steps here where the unidirectional carbon fiber is on the outside. There is one on the inside here. I feel a little step on the inside here where that unidirectional carbon fiber is, but on the inside it doesn't matter. It's not going to harm the aerodynamics or the structure at all. So really a very, very nice part. There are two exceptions. One, which you may or may not be able to see in the video, it's very hard to get this to show up. Right here is a not well bonded area. The fiberglass that's on the outside is not securely attached to the foam. This is partially due to possibly the weak vacuum bag I had. It could also be a little dip in the mold itself where we didn't get a tight fit. This has been a concern I've had all along in making the parts this way, and it's been a concern because nominally I paint the Mylar, that's the outer surface mold, first with epoxy paint, which gets bonded on to the part. When made that way, it is impossible to see or check for any of these voids. If you run your hand over it, you can hardly tell that there's a void there. Feels a little like a little dip, but if this were painted, you'd never know. Not painted, you can easily see it, and this is fixable. If you can find them, you can fix them. You can make a little hole, inject some epoxy underneath, spread it around, get that bond taken care of, and you'll have a good part. So that's an issue. And then here, where I put in the unidirectional pultruded carbon fiber rods, the rectangular ones here, I have a series of small spots where it's not bonded well. This is true on the outside and on the inside, and it's quite bumpy on the inside. It was very, very difficult. These unidirectional carbon fiber rods absolutely flush with the foam. Therefore, I'm rejecting this construction method, and I'm going to be bonding up the carbon fiber rods separate from the D-tube and bonding on the D-tube over the outside of those rods on a secondary basis, a secondary bond. So overall, an extremely nice part, very happy with it. The foam went around the mold without any issues. There's no cracking, no buckling. It really is a nice part, and I'm thrilled, as you can tell. Now, what you're also seeing in this video is a white covering that I've applied here. This would be used as a substitute for paint. This plastic covering is called Oracal 651. It is a vinyl with a solvent-based adhesive backing on it that is quote-unquote permanent. This material is rated for 5 to 6 years outdoors in all types of weather conditions. It's good up to about 165, 170 degrees of temperature. And believe it or not, it's currently being used on a couple of ultralight aircraft as paint. It is applied by squeegeeing it on right over the fabric of the aircraft, a Dacron with no paint on it. They squeegee this on, and it's the paint for the aircraft. It comes in a wide variety of colors. This vinyl is normally used for making lettering for outdoor signs. It's also very affordable. It's available on Amazon in narrow rolls, and you can special order and get it up to, I believe, widths of 80 inches. And I've applied it here dry. You can also apply it, there's a wet method for applying it. It's the same method that they use for putting vinyl coatings on cars, and it's used in a wide variety of areas. This material is really fantastic. It put on an incredibly smooth, really beautiful finish. If you use the wet method, you don't get any of these little air bubbles, which I'm sure aren't showing up in the video. I've applied this on some other surfaces. It really is a nifty material. Its only drawback is it is slightly heavier than epoxy paint. Epoxy paint for the entire aircraft would run about 5 pounds of total weight for the paint, somewhere between 4 and 5 pounds. This runs a little over 5 pounds, 5.5, 6 pounds. I believe that I can make up that difference in some other components and save some weight. This is going to be my go-to method for creating the finish on this aircraft. Solid surfaces, any of the leading edges or other solid surfaces will be coated with this material. Over time, if it gets scuffed, you can remove an area and just put a patch over the top of it. Won't bother a thing. It is called permanent, but you can get an edge lifted up, and you could put some solvent underneath this, like acetone, and begin to remove this if you needed to repair the aircraft, or if this got so scuffed up you wanted to put new finish on. It is removable. The one thing you cannot do with this material is heat shrink it or process it with any significant amount of heat. Heat causes it just to wrinkle and buckle up, and just not usable that way. But it is such a wonderful item. No toxic fumes from the epoxy paint. That's a big plus. Not messy, easy to apply, and it costs you just a little bit more weight. So overall, very happy with the D-tube. Going to use this methodology for building the actual aircraft. I might go with a slightly thicker foam. I'm going to run some tests with foam that's 2 millimeters instead of 1.2 millimeters. And leading edge is solid as can be, very durable. Really happy with the end results. Learned a lot from this test and have methodology for going forward. So thanks for sticking with me through this somewhat lengthy video, but we've learned a lot. I've learned a lot, and I hope you've learned something that you might be able to use in your future endeavors. And thanks for watching. Bye now.